my name is Tammy Miller. In this buffers video, we're going to learn to graphically determine the composition of a buffer. To graphically determine the composition of a buffer, we need to be able to look at a graph of a titration experiment to figure out where there is a great change in pH. Remember that buffers are solutions that resist change to pH, so we can add a lot of acid or base before the solution rapidly changes. Where the solution is rapidly changing is where we have reached that buffer capacity. Here's where we can determine that composition of the buffer. So first thing we need to do is we need to look and determine where on the graph the pH rapidly changes. And this is the volume of added acid or base that I will be using for the calculation. Here I'm going to use that volume that has been added to calculate the number of moles of added acid or base. As always, the number of moles, or the number of equivalents of acid or base, is what is reacting and telling me how much I have. For an added acid, the number of moles of added acid is always equal to the amount of conjugate base that is originally present in that buffer. On the other hand, when we have an added base, the number of moles of base that I have just added is the amount of the acid originally present in the buffer. And when we say amount, we're talking always about moles. Let's look at an apply question to determine how to use the graph. A student has 100 milliliters of a buffered solution composed of acetic acid and acetate ion. The total concentration of this buffer is 0.1 molar. The student is going to add 0.1 molar sodium hydroxide in 5 milliliter increments and measuring the pH after each addition. Based on the graph of the student's results, what is the concentration of my acetic acid and my acetate conjugate base originally present in the solution? So I'm going to look, and I see after 5, 10, and 15 mils, there's not a big change in pH. But all of a sudden, when I add 20 milliliters of my sodium hydroxide, I get this huge jump in pH. That means that is the volume that I'm going to use. So I'm going to come down here, and I notice that the volume is 20 milliliters of 0.1 molar sodium hydroxide. So since it took 20 milliliters, I need to figure out exactly how many moles of sodium hydroxide or how many moles of base I have added. So I have 0.02 liters, that's 20 milliliters, times the 0.1 molar concentration that was given to me up here in the question. So when I do that math, I find out that I added 0.002 moles of sodium hydroxide. Now, if the moles of base has completely neutralized the moles of my acetic acid, that means the moles of my acetic acid must be exactly equal to the moles of sodium hydroxide, thereby telling me that the number of moles of acetic acid is also 0.002 moles. So I'm going to come over here on the right side of my screen, and I'm going to write down that the CH3, COOH, or acetic acid, is equal to 0.002 moles. They're asking me for the concentration, so I need to take moles and I need to convert it into molarity. So I'm going to take the number of moles and I'm going to divide it by the volume that I have. And in the question, we're told that we have 100 milliliters of the buffered solution. This gives me 0.02 molar acetic acid. So I have now answered what is my concentration of acetic acid. And my concentration of acetic acid that I'm writing over on the right is 0.02 molar. They tell me in the question that the concentration of this buffer is 0.1 molar. That means this is the acetic acid plus that conjugate base of the acetate ion. So I have 0.02 molar acetic acid plus some molarity of acetate ion is going to equal 1 molar. When I subtract my 0.02 molar acetic acid from both sides of the equation, I find out that the molarity of my acetate ion is 0.1 minus 0.02, or 0.08 molar. This tells me that the original concentration of my conjugate base, or my acetate ion, is going to be 0.08 molar. There are a lot of questions that are asked of us in general chemistry about original concentrations of buffers and the base and acid that is present in a buffer solution. Being able to calculate them is going to make our understanding of acids and bases more clear.